Welcome back to Chapter 3 now, Week 2. Uh, making progress in the course. Hope you're all caught up and up to speed and enjoying tracking your participation so far. Keep it up. Keep up the good work. This is going to be Chapter 3. I am going to try to be more consistent with what I've promised of being shorter in the introductions to each of the chapters. So we'll see how we can do with that today. But Chapter 3 is talking about the system engineering design requirements, and it's essentially you need to look at taking a leadership role as a systems engineer. You need to take a leadership role in making sure that everybody is doing what they're supposed to do. Are all the players involved at the right level, or do they have the right enthusiasm for the position or for the project? In some ways, you might you treat yourself as a general contractor. You're not the owner necessarily. You're not the financer, but you are getting paid to make sure that this project gets built according to specs. And so one of the first things that the chapter starts to talk about is the different kinds of specifications. Specifications for ensuring that you're meeting the standards, meeting the expectations of the project. When you get to the end of the chapter, you'll remember that our end of chapter questions often refer to a kind of a group project. Question 2, I believe it is, at the end of the chapter, says that for a project of your choice, a system of your choice, define prepare a Type A specification. A Type A system specification includes technical, performance, operational, and support characteristics. And so what you need to do by the time that you've read this chapter is understand what that means: technical, performance, operation, and support. And prepare this Type A spec. Now hopefully you have worked and have completed your decided what project you are all going to work on, who your team is, and that this project, this can actually be a spec that could be part of your final project. So it will help you get well on your way for preparing this the final project. The systems engineering management plan obviously has to have specs. And so you're going to be writing the Type A spec for that within the next few days after you've completed reading this particular chapter. And so, again, get your team together, get working. Otherwise, you have to pick one on your own and ultimately may have to do another one for the final project. So I think it'll be more efficient for the project, more efficient in your time if you can do that a little bit earlier on. The next thing that this chapter does is spends a lot of time talking about the different engineering disciplines that are involved in a system. I don't think it's that important to understand and to pay attention to everything that every one of those engineers has to do. Remember, as the team leader, you don't have to be an expert in all of that, but you're a manager. You have to manage people. There are several pages of equations for reliability engineers. Well, I think that's important if you're a reliability engineer. To know how to do that, that's it may not be worth the time to completely follow that through. That being said, if you are running a system and you have reliability engineers checking on reliability, it is important that you know what they're talking about. And so this just gives you a little bit of a breakdown. And so going through the list, everybody thinks they're an engineer and loves to put the word engineering behind their disciplines. But this really starts to talk about a lot of the engineers that you will be working with, because these engineers may not have this on their degree title, but it's certainly where they have become experts, and so they know what they're talking about. But the chapter starts to talk about software design, reliability, maintainability, human factors, safety, security, manufacturing, production, logistics and support, disposability, quality, environmental, and life cycle costing. So we have experts that are doing all of these things, and you as the systems engineer are responsible to ensure they're doing their job, and that you're going to be able to integrate all of these engineers to put them into a team, to bring them in at the right time, at the right stage of the process to help you implement the full life cycle of this project, from initial concept to production, through use, improvement, maintainability, all the way through the end of its useful life and disposability, all in a socio-economical and environmental appropriate way to dispose of those projects. So chapter 3 is a relatively quick read, and so that's good. Some of the first 2 chapters were new terms, may have been new news to you. This is things that you should have heard of by now in your careers, and like I said, it's a relatively quick read and it shouldn't take you too long to read through it, but do spend some time on that Type A spec chapter 2 and on any of the other questions that you think might be important. I would pay particular attention to the quality discussions. I think quality is an important word, because it means different things to different people. But from my perspective, quality doesn't mean better or worse. It means consistent with the goals. And so you set the goals. If you meet those goals, that's high quality. That doesn't mean, like I said, that it's the highest quality. They may have another product that has higher goals, and we meet that. But quality is meeting the goals. And so think about that as you look at part of your project and your specifications. What are the goals? What are the parameters? What has to be done? And how can I ensure that we meet that so we have a high quality project and product? So again, good luck with that. We're going to read 2 chapters this week, chapter 3, chapter 4, and we're moving right along. So next time I talk to you, it'll be through chapter 4. Have a great day.